Hey guys, welcome back. So today we'll be reviewing laws of exponents with examples. And just a quick review, the first one that we do have on deck, and I'm going to put little numbers here. Remember that the a to the n power equals a times a times a, whatever your n factors are. So for an example, if we had a to the 1 power, that's going to give us a. If we had a to the 2nd power, this is going to be a times a. If you had a to the 3rd power, this is going to be a times a times a. And let's use numbers. 3 to the 1 power equals 3. 3 to the 2nd power equals 3 times 3, which is going to equal 9. And then 3 to the 3rd power is 3 times 3 times 3, and this is going to equal 27. Next, when you are multiplying two expressions with the same base, you're going to keep your base and you're going to add the exponents. So for an example, let's say we had 2 to the 2nd power times 2 to the 4th power. Notice here my bases are the same, so I'm going to add my exponents. So I'm keeping my base, it's going to be 2, so I'm adding my exponents, 2 plus 4, and you're going to be left with 2 to the 6th power. Let's try negative 3 squared times negative 3 to the 3rd power. So my base is negative 3, so if I have the same base, I'm going to add my exponents. I'm going to write my negative 3 here, and I'm going to add 2 plus 3. So my answer is going to be negative 3 to the 5th power. What about 4 times 4 to the 2nd power? This is going to be 4, 1 plus 2, because you have like an imaginary 1 here. And this is going to give you 4 to the 3rd power. And then what about x to the 5th power times x to the 3rd power? Same thing, my base here is x, so that's going to stay the same. However, I will add my 5 plus my 3, and this is going to equal x to the 8th power. Okay, next. So this law here, law number 3, if you have a power raised to another power, then you're going to keep your base and you're going to multiply the powers. So for an example, if I had 2 cubed raised to the power of 2, my base is going to stay the same. However, I will be multiplying my powers. So 2, 3 times 2, and this is going to give me 2 to the 6th power. If I had x cubed raised to the 5th power, my base is going to stay the same, and I'm going to multiply 3 times 5. So we're going to get x to the 15th power. What about if I had a bracket and parentheses? So let's say we had bracket, parentheses, negative 2 cubed, and I had a bracket with a 2 on the outside. It's the same thing, right? You still have a power raised to a power. I'm still going to multiply the 3 and the 2. My base will stay the same, which is the negative 2. And I'm going to multiply 3 times 2. This is going to give me 6. So your answer is going to be negative 2 to the 6th power. So let's try this example here. So notice that my base is 7. I have a power raised to a power. I know that I need to multiply. So 7, 2 times 4, and then you have times 7 to the 3rd power. 7, 2 times 4 is 8 to the 8th power times 7 to the 3rd power. All right, and notice here, I am now multiplying two expressions with the same base. I'm going to add my exponents, just like we did for law number 2. So here I'm going to get 7 and then 8 plus 3. And this is going to give you 11. So your answer is going to be 7 to the 11th power. Next, law number 4, if you have a product raised to the power, n will now become an exponent for the a, and this n will also become an exponent for the b. So this will be an times bn. So let's look at this example here. I have a product raised to a power. This 3 will now become the power for the 2 and the x. So this is going to equal 2 to the 3rd times x to the 3rd. We're going to simplify. 2 cubed is going to give me 8, and then you have times x cubed, and your final answer is going to be 8x cubed. What about 3x raised to the second power. I'm going to have 3 squared times x squared. 3 squared is 9 times x squared. And when you multiply together, you're going to get 9x squared. All right, let's try this example here. So this 4 is going to the 2. It's going to be multiplied here, and it's going here, okay? So this is going to be 2 to the 4th power times x 3 times 4 times y to the 4th power. So let's simplify. 2 to the 4th power is going to give me 16 times x to the 12 times y 4th. Since I cannot simplify any further, I'm going to be left with 16x to the 12th power times y to the 4th power. So let's try negative 4y to the 3rd power. I'm going to do the same thing here. So we have negative 4 raised to the 3rd power times y to the 3rd. Negative 4 cubed is going to give us 64 times y cubed. 64 times y cubed, you're going to get 64y cubed as your final answer. Okay, let's try this example here. So notice we do have 2 expressions, but first we're going to start with this expression here. So first we're going to get 2 to the 4th power times x to the 4th power times y 3 times 4. This expression here, we have x squared times y as well. All right, so first thing I can do, I can simplify this 2 to the 4th power, and that's going to give me 16. That's 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and that's what we have here. Then we're going to multiply 16. Then we have times x to the 4th power times y to the 12th power times x squared times y. And just by looking at this, I can simplify my x to the 4 and the x squared. I can also simplify the y12 and the y. So we're going to get 16 times x 4 plus 2 times y 12 plus 1. This is going to be 16 times x to the 6 times y to the 13. Since I cannot simplify my answer any further, your final answer is going to be 16 x to the 6 times y to the 13. This is your final answer here. All right, so law number 5. If you are dividing 2 expressions and they have the same base, you're going to subtract the exponent in the denominator from the exponent in the numerator. So this is going to look like m minus n, given that m is greater than n. So for an example, if we had 3 to the 7th divided by 3 to the 5th. My bases are the same, so I am going to subtract. This is going to turn into 3, 7 minus 5, which is going to be 3 to the 2nd power. And this is going to give you 9. What about negative 2 to the 8th power over negative 2 to the 5th power? So same thing, my base is negative 2. 8 minus 5, this is going to give me negative 2 to the 3rd power. 8 minus 5 is 3. So negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is a positive 4. Positive 4 times a negative 2 is going to give you a negative 8. So your answer here is going to be negative 8. So let's try this example here. My base is negative 6. So I'm keeping my base. And I'm going to subtract 4 minus 1. This is going to give me negative 6 to the 3rd power. It's going to give you negative 216. So let's try this example. Notice here my base is 4. So I'm keeping my base. I'm going to subtract 3 minus 2. This is going to be 4 to the 1st power, which is going to equal 4. Now let's look at law number 6. So what happens if the exponent in the denominator is greater than the exponent in the numerator? Then you're going to get 1 over a n minus n. So for an example, so let's say we had -3 to the 5th power over -3 to the 8th power. Notice my power in the denominator is larger than the power in the numerator. So I'm going to rewrite just like this law right here. So this is going to become 1 over -3, 8 minus 5. This is going to be 1 over -3 to the 3rd power. -3 times -3 times -3. -3 times -3 is a +9. +9 times a -3 is a -27. So this is going to become 1 over -27. So let's try x squared divided by x to the 4th. So my base is the same. I'm keeping my base. So this is going to turn into 1 over x 4 minus 2, which equals 1 over x squared. 4 minus 2 is 2. And I cannot simplify any further, so this is my answer here. 2 divided by 2 to the 8th. So my base is 2, staying the same. So I'm going to rewrite 1 over 2, 8 minus 1. Remember, you have an imaginary 1 right here. And this is going to give you 1 over 2 to the 7th power, which simplifies to 1 over 128. Let's try one more. Let's try 3 divided by 3 to the 6th. This is going to be written as 1 over 3, 6 minus 1. Going to get 1 over 3 to the 5th power, or you're going to get 1 over 243. So that is it for part 1 of 2. Please do check out part 2 if you want to see the rest of the laws of exponents, okay? So that is it for this part of the video, and I will see you guys in the next video. Bye, guys.